Thank you for the introduction and thanks for having me. Yes, we'll talk about Class 8 big rig trucks today, but more specifically about ODD coverage. And there were a couple of things that I already saw in the startup pitch just now, which will probably resonate with you when you see my slides. What does it actually mean to make level 4 safe? So you probably heard the question, how safe is safe enough? On first glance, we might think that's a mere testing problem. Run enough scenarios, you collect enough data, and you then demonstrate the performance of your system and you're good to go. But what if that is more complex of a challenge? Basically about defining and understanding the world in which the system is expected to operate. And that's exactly where the concept of operational design domain, the ODD, and subsequently also ODD coverage comes in. And that's what we'll touch upon today. I have 4 brief points I want to cover with you today. I'll begin with the mindset shift on the way to SAE Level 4 development. We heard a little bit of that in the keynote this morning already, specifically from regulatory side. Then I will touch briefly on our partnership setup with Aurora, before then moving into ODD definition and also what does a meaningful ODD coverage mean. And given the limited time that we have here, this will be more of a high-level overview, not a complete answer, but I hope it serves as a starting point, which we then would also be able to cover at 16:45 later on. There's a challenge your peer session where you can come and we can discuss. I think it's in the exhibition hall. So let's start with the first one. The mindset shift on the way to SAE Level 4. Basically, challenges that we see is, and we heard that today a couple of times already, there's a fundamental change in the responsibility model in driving. So you no longer have a human fallback, but you have a system that has to do the entire dynamic driving task. At the same time, Level 4 systems face what is often referred to as an open world or open context problem. And that means that the system must operate safely in environments that cannot be fully specified at the time of the design of the ADS. This leads then in the end to the key challenge, which is the infinite complexity of real-world traffic. What are some solutions? That shift has direct consequence for how we think about ODD. The ODD is no longer just something you nicely describe and you put it in your shelf and that's it. It becomes a central safety artifact central artifact in engineering, which guides the entire development lifecycle and even beyond after SOP. It also needs to serve as a single point of knowledge, a single source of truth for everyone involved, may it be safety, may it be development or verification. And at its core, the challenge is to map a multi-dimensional open context into a finite, manageable set of testable scenarios, while still capturing the relevant dynamics of real-world driving. This brings me to the second point, the strategic partnership we have with Aurora. Because this mindset shift is not just theoretical, it directly shapes how Level 4 is developed and organized in practice. And this is what I'm talking about now. So what you see here is basically the setup we have with our strategic partner, Aurora. There's much more online that you can find. It's much more extensive. It'll go in depth to who specifically does what. So I'll just cover briefly on the high level here. Basically, Aurora and us, we are bringing scalable, autonomous Level 4 truck driving on the streets. We industrialize the hardware that they need for their driving stack, and they sell the system as a driver as a service system to customers, namely OEMs, who then in turn again sell their trucks with the AD stack to transportation companies or fleets and such. And we don't only deliver the hardware, but we also deliver the AD safety path or the fallback path for that system. And I do have to add also the whole servitization we do. So once the hardware fails later on during operations, we also take care of that and we ramp up the organization for that as well on our end. On the hardware side, here's a brief overview of what you can see. So we talk about several pods on the truck. We talk about several various sensors in each pod that we integrate. But not only that, we also provide the cleaning for those sensors. We provide the harnessing, the wire harnessing. We also provide up to 4 ADCUs, automated driving control units, so basically the brain of the whole AD stack. And there you see on top, we do have the central pod, with also including the Aurora developed LiDAR, which we do industrialize for them. And then on the sides, you have the side pods, as well as on the bottom, in the middle, you have the front pod. That's for the hardware side, and now we come to the software side, the fallback path. We are basically there if the main path fails, and we have to enable the truck to come to a safe stop, in a nutshell. Whether it be on the highway, whether it be on a road between the highway and the hub, wherever it's driving, we have to be able to take over from the main path and then bring it to a safe stop, a minimal risk zone, so to speak. How do we connect that to the ODD, basically? So this is taken from one of the latest investor relation presentations from Aurora, how they are currently operating. So you do have in the middle bottom, you have Texas, and they have a lane between Houston and Dallas running in both ways, and then also Dallas going to El Paso, which is a 1,000-mile stretch, almost. If you go all the way to Phoenix, it'll be 1,000 miles, so you can't do that with a normal human driver, but an ADS driver will be able to do that. And the interesting thing is, once we start in SOP, which is next year, we'll be covering what you see right now, most likely, we call it the Sun Belt. But that's not where it stops, obviously. Down in operations, we will have to cover all of the US, if legally permitted, of course. You can see California here is not included due to some regulatory challenges that still exist. But this also shows you that an ODD is nothing you have once defined and then it's done. It's something that evolves even past SOP. And this is where we come to the ODD definition for our SAE L4 ADS. ODD is something that didn't just drop out of heaven. It's something that has been worked on quite for a while. To my knowledge, the earliest document I could find is the well-known SAE J3016 from 2016, that update, not the original one, where they first basically introduced from SAE side the term ODD. Then we had Pegasus and then subsequently VVM here in Europe, or basically in Germany, programs, PPPs that were public projects that were working on specifically those topics, how to develop ADS, the whole scenario space, and then also validation methods and such. So they were covering a lot of ODD. Then we have in 2020, a couple of documents came out, so very late 2019, as you can see at the top right from the UNECE, the ADS regulation from the GRVA group, that had, I think, over 200 mentions of ODD in it. And then you have from SAE a best practice for describing an operational design domain, conceptual framework, and lexicon. Covered a lot of that. Then there's a BSI standard from the UK that came out. Subsequently, also an ISO came out in 2023, ISO 3450X series, where 3 is the one defining the taxonomy of ODD. And then in the more recent years, 2023 and 2025, we have another document coming out from BSI and also the ASAM Open ODD format description, basically. So what I want to show here is that it's nothing that we've just explored and we're just now working on it. It's been a while, and it took a long while to harmonize it, and we're still not there. So if you talk to someone in the US, they have maybe a different understanding of ODD if they use more the SAE terminology and such than if you talk to someone using ISO. And we, in essence, are using ISO for our project. This is what I want to highlight now. There we go. We, in ISO, find that it's a standard, the ISO 34503. It's a standard applicable for level 3 and level 4. I'm here only talking about level 4. Because the ISO also includes a lot of other things that are not applicable to level 4, like you have to watch the driver behavior and such, but there's no driver in level 4. So we won't cover that in our ODD definition. It introduces the terms, definitions for OD, TOD, ODD, and COD, so a lot of abbreviations, and multiple people understand different things. For example, the VVM project that I just mentioned said OD is TOD, so operational design and operational domain equals target operational domain, you could now basically say, okay, what's the deal? But per definition in the ISO, it's basically the OD, the operational domain, is the universe, so everything that's out there. Then the target operational domain is the wish list. This is where we wish to drive with our ADS, with our level 4. The ODD, as we define it, is the capabilities, the conditions where our stack needs to perform safely. Safely is interesting in the ISO because it's not mentioned in other standards when you look into the ODD definition. And then the COD would be if you're driving around where you currently are, this is the current operational domain that you're in. If you want to dive more into that, we can talk later, or you go and read also the ISO document. Basic info is that it's a standard that enables us to define the ODD in a hierarchical way, using basically 3 categories. You already saw that shortly. It goes from ODD elements and then into scenery elements, which is basically static scenery elements, environmental conditions such as weather, and dynamic and static elements, if you so will, that is any driving object and such. The numbers that you see there is not from the ISO. It's basically to give you a kind of idea, it's not the exact numbers, of what our initial ODD definition looked like. So it was a big listing of a lot of elements that we thought we would encounter in our ODD. We have ever since reduced it actually by quite a number of elements due to different insights from the field. So ODD is nothing, as I said in the beginning, and as also the colleague before me said, it's nothing that you just throw out there and it's static. You have an initial ODD definition at the design. You then have development. You develop your ADS, and this is what we are doing currently. And then at some point, you're working towards SOP. But SOP also then is not the end. And during this whole time of development, you are finding things in your data, you are finding things maybe that you're exploring through open data that you see, okay, the infrastructure looks different in a certain state. There are certain rules that we have to take care of in different federal states of the US. And all those things come into play, and basically you're continuously refining, you're updating your ODD definition as you go. And you need to be, of course, in contact with everyone involved, with the safety, with the verification guys, and then also specifically with development. And as I said earlier, SOP is probably not the end. If you keep driving, you keep exploring, you see things you haven't seen before that you couldn't dream of. I come from accident research actually background. You wouldn't be able to imagine what kind of stupid accidents actually happen if you hadn't seen them before. And this is basically what I think of what we will encounter when we drive around with our ADS level 4 truck. So in essence, ODD is an iterative process throughout the whole development and even beyond. And specifically on the lower part, the refinement through feedback, for example, from the field, I want to point you to my colleague, Dr. Christopher Pinke. He will have a keynote tomorrow afternoon, I believe it is, on specifically how we deal with data and how the data management basically is in that project. That brings us to the key question. If the ODD is continuously evolving and the operational environment is inherently complex, how do we ensure that it's actually covered in a meaningful way? So we heard ODD coverage or coverage every now and then today as well. So what does it actually mean? When we talk about coverage, at times there's completeness and coverage kind of mixed in between, so I want to clarify that at least from our understanding what it is. And we can again discuss this afterwards if we want to. So completeness basically refers to whether an ODD itself has been fully and correctly defined, so the definition with the taxonomy from the ISO, for example, and the definition of the ODD. In other words, whether all relevant parameters, if you so will, all those elements that we talked about, are being considered in that definition itself. Coverage on the other side, if you take that over on the right, is then what refers to how well this ODD is defined, how well this defined ODD has been exercised during testing and validation. So for what I have defined, do I actually see that in my data? And here you can already guess, if I don't define so much, I can say, hey, I have a great coverage, right? My coverage is 100%, but yeah, maybe you didn't define it right. Maybe you didn't define it extensively. Of course, your coverage will be perfect. And if you have that on element level, you can play the whole thing on the scenario level as well. And this is again coming back to why do we do all these things? Regulation says do ODD coverage and make it safe. And that's about all they give you. The rest you kind of have to figure out yourself, and as we heard, you have to talk with a lot of people, be in contact and so on. But this is basically where you can tweak it in the wrong way, let's say that, right? So don't define it right, you have great coverage. Challenge now is that while those standards that we looked at, they provide taxonomies for the ODD, we don't really have a measurable criteria for what it means good coverage, right? So in practice, there's no common understanding of what basically constitutes enough coverage. And different developers rely on different assumptions and different metrics. And this too I don't have from somewhere. We looked at literature of the last, I don't know how many years, 5 years, and looked at, okay, how did people understand ODD coverage? Or what do they mean by coverage? How did they apply it? Of course, we understand in the last 5 years, if you remember the chart of the standards, a lot of standards just evolved, a lot of formats just happened, a lot of discussion in public projects and so on. So I understand it's not I look into the literature, I get the perfect answer, and now I'm beating, and I don't find the right answer, now I'm beating on those people. That's not my point. But my point that I'm trying to bring across is we're not there yet with regards to ODD coverage. So this is also basically what I want you to take away for later discussions, or take it home. There's lots of ways to define coverage, lots of ways to do coverage. You can go from underestimation, I would say, potential underestimation, if you just go with qualitative checklists and say, okay, I've done this, I've done that. I've seen one red car in my data, fine, I covered red cars. I've seen one pedestrian running from left to right, great, I covered all pedestrians, and so on. You can stay on that level and say, hey, I defined it well, or I covered it well, and we're good. But then you can also move forward and say, okay, look at structured and logic-based approaches with taxonomies and hierarchical models. What a word. These provide traceability and clearer design rationality, and this is where most of the current ADS programs operate, right? You have the taxonomy, you have a definition, and this is the space you're in basically on element level, and maybe you're moving to operational situations as the GRVA says, as the UNECE, or as we talk scenarios. But then you can even go beyond that on the third one. You can go into quantitative approaches using statistical representations, such as probability distributions, to ensure that testing reflects real-world conditions and variability. Basically saying, okay, how often do I have to see what? And then I go and drive and see that I find all those kinds of possible parameter combinations. And then on the very far end, we have let's do everything. We have all the money in the world, we can do everything. This is mostly theoretical papers that you read. They suggest that. There you go, and you have, okay, I have 100 offsets, and I know that one offset doesn't come by itself. So one scenario most often doesn't come by itself. If you came here by car and you drove on the highway, you're probably not only passing someone, but while you're passing, someone else is passing you, and there's a cut-in in front of you, and somebody behind you is doing something else. So the real world doesn't look, okay, here's one scenario, there's another scenario, and here's yet another one. But it's a mixture of everything, and to find that data, to find this basically possibility to cover all that and to especially say what is relevant and to then argue that in the safety case. This is basically where we have to discuss. This is where we have to come to more harmonization across the whole board basically of what it means to approach the whole topic of ODD coverage. So again, as I said before, there is not the one-size-fits-all solution, and we're not there yet. I think as long as it took us to define ODD itself, it probably will take us another couple of years to define what we mean by ODD coverage. There was even just an update in the UNECE GRVA regulation where they adapted the whole document and changed some things, specifically in regards to what it means to be a competent and careful driver. And there we see there's a lot of things going on the regulation side, and there's a lot of things going on, of course, in praxis. We have not only us are driving outside, we know that in level 4, there's others as well. But this praxis, this experience needs to be fed back into regulation so that we can come to a good understanding of what it means to cover the ODD. And with that, I want to thank you, and I'm here for any questions.
Perfect. Just in time, on the second. Great.